So in this problem, they want us to do more than just find the derivative. What they're asking us in this problem is to evaluate f prime of 2. Now what that means is we need to find the derivative of the function and then evaluate it at 2. So the first thing I'm going to do is find the derivative. So I've got f prime of t equals, and I ask myself, what do I need to do to find the derivative of this function? Now you can see that I have an inside 1 minus t squared being raised to the outside cube, so I know I'm going to have to use the chain rule. So understood to be in front of the parentheses is a 1, so I'm going to do the exponent 3 times 1, which gives me 3 times, and now I'm not going to change the inside, 1 minus t squared, okay, and then I'll reduce the power by 1, so this 3 minus 1 equals 2, and then I'll multiply by the derivative of the inside. So I say to myself, I look only at the inside and I say, what is the derivative of this? Well, it's just negative 2t. Okay, so now that's the derivative, and all we have to do, it's not even necessary that we simplify this function. We just need to evaluate it at 2. So what I'm going to do is everywhere I see a t, I'm going to put a 2 in its place. So I've got f prime of 2 equals 3 times 1 minus, and in the place of the t, I'm going to put a 2 squared, all squared, times negative 2, and in the place of t, I'm going to put a 2. And so let's look at what we got. We had a t here, and I put a 2 in its place. And we've got a t here, and I put a 2 in its place. Now notice we're plugging the 2 into the derivative because the problem says what's f prime of 2, not what is f of 2. And so I've got f prime of 2 equals 3. Now 2 squared is 4, and 1 minus 4 is negative 3. So I've got negative 3 squared, and negative 2 times negative 2, or times positive 2 would be negative 4. Okay, let's keep evaluating. F prime of 2 equals 3. Negative 3 squared is 9 times negative 4. And so I've got f prime of 2 equals 3 times 9 is 27 times negative 4 is negative 108. And so the answer is f prime of 2 equals negative 108. We evaluated the original function up here by plugging in 2, f prime of 2, and we got, so the slope of the tangent line of this function at 2 is negative 108, so it's going down very, very steeply. So let's do another problem just like the previous. In this case, they want us to evaluate this function at 5 with the derivative. So they want to know what is f prime of 5. Well, what I'm given is f of x, and so I'm going to have to calculate the derivative and then plug 5 in for it. And so first I'm going to rewrite this function where it does not have a square root. So I'm going to write f of x equals x squared minus 3x minus 1, all to the 1/2 power. Okay, so what I have written right here is exactly the same as this. Something that's being taken the square root of, it's the same as if you raise it to the 1/2 power. And so understood to be in front of the function is a 1. And so I can see I have an inside and an outside, so I'm going to use the chain rule. 1/2 times 1 is 1/2, and so I've got f prime of x equals 1/2 times x squared minus 3x minus 1. And then I take and I reduce this power by 1, so subtracting by 1 is the same thing as subtracting by 2 over 2, which I have to do because I need a common denominator. And so it's to the negative 1/2 power. But what I haven't accounted for is I have not accounted for the derivative of the inside. I need to know what is the derivative of the inside, and I need to multiply it. That's where my chain comes. So I've got times, and the derivative of the inside is going to be 2x minus 3. And so what you see here is your derivative. Let's clean it up some. So I've got f prime of x equals, now this will be on top, so I've got 2x minus 3 on top. On bottom, this 2 goes on bottom. And now you can see this whole entire function is being raised to the negative 1/2 power. So if I move it to the bottom, it'll be to the positive. And raising to the 1/2 is the same thing as square root. So I'm going to write square root of x squared minus 3x minus 1. Okay, so now this is a real clean version of our derivative. And in the problem, they want us to evaluate it at 5. So I'm calculating what is f prime of 5. Well, now I can do that because I know what f prime of x is. It's this. And I'm going to plug 5 in everywhere I see an x. Here, and here, and here. So let's write it out where I have a 5 in for all the x's. 2 times, and in the place of x, I'm going to put a 5, minus 3, over 2 square root of, and in the place of x, here, I'm going to put a 5, minus 3 times, and in the place of x, I'm going to put a 5, minus 1. And so now all I need to do is evaluate this. 2 times 5 is 10, minus 3 is 7, over, and then I say, okay, 5 squared is 25, minus 15, minus 1. So I've got 25 minus 15 is 10, minus 1 is 9, okay? And the square root of 9 is 3. So on bottom I've got 2 times all this, which is 3, so I get 6. Now let's move all this so we have a little more space. And let's write our answer nice and clean. So I'm saying that f prime of 5 equals 7 over 6. Now 7 over 6 is approximately, 7 divided by 6 is approximately 1.167. And so what we're saying is when when x equals 5, our graph is going up at a rate of 1.167, which is really slow. So our graph is almost flat, maybe like this.